Goodbye shopping and welcome to part 10, where we start with our astrophotography process or workflow, however you want to call it. And step 1 is about the preparation. This is the moment where we decide what we're going to shoot, where we're going to shoot it, when we're going to shoot it, and what equipment we need for that. And how we decide all that, we cover right after the trailer. So let's dive right into the preparation. So as stated, the first thing we have to decide is what we're going to shoot. And that depends on many different things. First, what's actually available on the menu. And that really decides on what time of the year it is and where you are stationed geographically. The Northern Hemisphere has another menu than the Southern Hemisphere. And while, for example, in the early summer, it's galaxy season as the Milky Way dives practically away. In late fall, all the beautiful nebulas like the Orion Nebula, the Horsehead Nebula, and many more appear. And if you are in any Facebook or Instagram groups, you actually realize that seasonal, some objects suddenly, like the plague, are all over. So how we will see what's on the menu, we will check later on the computer. But let's assume now that you know the whole menu of the season. How do you decide? First of all, depending on where you shoot, you might have a blocked vision in certain areas. For example, I shoot from my terrace. To the east is my house. So any objects in the east, I can just scribble off my menu. Or I would have to move somewhere else, which I'm usually too lazy. So the next thing that's important, where and how big is the moon? If there's no moon, you can shoot about any object. If the moon is full, you probably shouldn't shoot an object very close to the moon, and you probably should rather shoot a narrowband object, as you can use there the filter to filter out the moonlight. The next question is, how big is your object? If you decided to go with a 200mm focal length, and your object of desire is a tiny little galaxy or planetary nebula, probably that's not so ideal. If you decided to go with 700 or 800mm and your object is a giant nebula, which has about 4 times the size of your field of view, probably also not such a good choice. So the focal length and your object should match. Also, how long is the night? If you're in the middle of summer in Scotland and you have about 1 hour of real darkness, probably to approach a very faint nebula is not such a great idea, where you would need 20 or 30 hours of exposure. On the other side, a very long winter night might be exactly prone to go after such a faint object. So you see, there's a multitude of things to consider when you choose your object. And as a beginner, always start with the easy ones. And if you ask which are the easy ones, exactly the ones you always see in millions and millions and millions over Facebook, Instagram, and so on. There's a reason that they're so popular. Now, if you have actually decided on your object, the next thing you have to decide is where you're going to shoot. Do you shoot from home or do you shoot somewhere else? Sometimes you're in the luxurious position to really have a choice, and a lot of times you're actually forced to do one or the other based on a lot of reasons. If you decide you shoot from home, your search for a place is over and you can go to the next step. But if you want to go to a dark side, the question is, where is this dark side? How can you find this? For that you need to know that we measure the brightness of the sky in Bortle. The Bortle scale goes from 1 to 9. 1 being completely, totally dark. Every astrophotographer's dream. Portal 9 is almost daylight. A huge city with a lot of city lights who make astrophotography almost impossible. Almost because they are very courageous, innovative people like Queef, the lazy geek, who actually shoots right out of the middle of Tokyo. And he makes beautiful pictures. So it is possible actually to shoot even in a Portal 9, but for sure it is more difficult, and for sure you will never get the same results as when you shoot in a dark side. Now personally I live in a Portal 5 area and I never had issues to shoot from home, but for the few times I went to a dark side with my scope, it still blew my mind what is possible when you're in a Portal 3 area, for example. So the question stays, how can you figure out where you best space in a certain range where you don't want to go further is? And we will look also at that in a moment at the computer. There's special maps for that where you can actually research that. So now we know the object and we know from where we're going to shoot the object. Next point, when? Probably, preferably tonight. But is that possible? Depends on the weather. Now the first thing you want to check, is there any chance of rain tonight or the night after or whenever you want to shoot? If you do not want to stay the whole night up and you want to go to sleep while your rig is shooting, this is absolutely totally key that you're 100% sure or 99.999% sure that there will be no rain, no thunderstorm, nothing. So to diligently look at that as good as you can in the different weather forecast apps is quite crucial. But is no rain enough? Obviously not. Because we need clear sky. Clear sky means no clouds and also no haze, dust, fog, whatever else could come between us and the stars. They're very specialized apps for that, who will show you that and also forecast you that for a week or even more, with the usual accuracy such forecasts have. And once again, in a moment at the computer, we will look at these apps and how you use that to find your perfect date for doing the astrophoto. So now the last thing we need to do is to decide what equipment we need and to prepare it. So for example, if we have different telescopes, which focal length is ideal? If we have different filters, what filter will we use to shoot the object? And again, if we go into a dark side, the logistics with having the battery loaded, with having everything that you stay warm and so on is much bigger than when you do it from home. But trust me when I tell you that it makes sense to double and triple check if you have everything with you when you go to a dark side. There are just too many stories in the internet floating around where people drove 3, 4, 5 hours into the desert just to realize that they forgot one crucial piece of equipment and could simply turn around and go home again. I don't want that happens to you. So now I described nicely to you what is all needed until you're ready, until you're prepared. But obviously you want to know now exactly how this is all done. And so we go now to the computer and have a look at it. Welcome to my computer and welcome to Starry Night 8. Starry Night 8 is one of the many Planetarium softwares that you can use to figure out what objects to choose. Now there are two approaches here. One is that you choose an application like Starry Night on your PC or Mac. Advantage is you have more graphics power, you have a bigger screen, you can sit comfortably. Disadvantage is it might be hard for you to figure out if that really is a place where you could shoot or if your site is blocked. The other option is that you use an iOS or Android app and go with your cell phone outside, where the compass will automatically show you right at the sky what there is to see. So personally, I'm more the smartphone guy. I like to go on my terrace when the rig is already installed and just look around with my smartphone and think, today I'll do this or that object. But let's start here with this one. So you already see here the main advantage of Starry Night. It's just beautiful. It's just the Milky Way here, everything. It's just so beautifully displayed. What you see here as green is that I actually entered my custom horizon in this app, which has the advantage that I really see where my view is blocked. Here is a tree, and here east is the upper part of the house. So whatever is here, I'm so sorry, I cannot shoot it. If you're interested in Starry Night and also in this custom horizon, I will link some videos about that in the description. So let's go back to our Milky Way, where usually the nebulas are. What you also see here in the middle is this blue box. And that's the field of view of my 103 APO, so 700mm focal length, combined with the APS-C sensor that my camera has. So now I can go, oh, Eagle Nebula. Let's see, let's zoom in. Yeah, that would fit quite nicely. I have still a lot of space around it, and the Eagle Nebula is fully in there. Same here with the Omega Nebula. And so if I'm interested, I can actually click on it and I get some additional information like when it rises, when the transit is, so the highest point on the sky, and when it actually sets. I also get here the apparent magnitude, so how bright the object is. The smaller the number, the brighter it is. A brightness of 6 is still visible with a telescope with a naked eye and can very comfortably be shot with a camera. You can also get a description and some other stuff. And before we go to this app here, if you would like a free app, be it on your computer or on your smartphone, Stellarium is a very good choice. Personally, on my portable devices, I use this app here, which is Sky Safari. But I think already by comparison of what we have seen before, you see that on portable devices, it looks much simpler. But in principle, we have exactly the same again. We have here this little blue box, which shows my telescope, my field of view. And for example, what do we have here? Andromeda Galaxy. That sounds interesting. Let's look if I can squeeze it in with my scope, and nope. But by the way, there is always the possibility of a mosaic, which means that we would do 2 pictures, one for example here and one here, or we put them upside down, make 2, and then sometimes it's good enough we could also do 3 and then merge the whole thing together. It's how you have done panoramas before your cell phone actually stitched it together automatically. Also here with Sky Safari, I can do exactly the same. I can get a lot more information also with the rising, the transit, the setting, which is actually the most important thing that you need. And by the way, with all of these apps, you can actually change the date and the time. So if you plan to shoot in 3 or 4 days, you can just adjust this so that you can look how the sky will look at this point of time. Also on the smart devices, Sky Safari is by far not the only app which you could download. There are tons of them. From my perspective, Sky Safari is the best one, but there are other ones who come really, really close. And also here, the cool part is that we can go on to night. And now you can see if I scroll down that it will first tell me about the solar system, and afterwards it gives me the best deep sky objects to shoot tonight. If I go here and view all, I get tons of objects. I see right away when it rises, when it sets, And that's a little bit what I meant when I was talking about the menu. Now, before we leave this topic, I want to show you this website, which is free and which you should absolutely look at. And it's called telescopius.com. So the cool part is you can enter here your telescope data, and then you can click here on targets for your telescope. And you can enter here a ton of search parameters. For example, from when to when does it have to be visible? The minimum altitude in the sky, what object type. If you want a dark nebula or a galaxy, for example, let's choose galaxies. Now we get only galaxies here. Even the distance from the moon. So it's very easy this way to get to exactly the object that you want. And that's now another way how to look out for your object beside a planetarium map. Now it has another cool feature, and we see that down here. As we've seen before, my telescope is too narrow for Andromeda, but I want to make a photo of Andromeda. What can I do? Well, first of all, I can click here on telescope, and I can say, well, I have a reducer, which is 0.8. Is it big enough now? It's not yet 100% clear. Let's turn it. I can do that here when I go on camera. I can turn it. And well, it's tight. It's really tight. So if you want all the faint areas of Andromeda, it's still too tight. So what can we do? As we've heard, a mosaic. How we do that? We go here on the one-on-one, and we say, well, we want to have 2 tiles horizontally and 2 tiles vertically. We can also decide how much they should overlap. Usually it's about 10%. Now let's see. And look at that. Now it looks much better. We can obviously also rotate that if we want until we're 100% happy. And now you might be saying, okay, this is nice, but how do I remember that? And how do I enter all this mosaic into my software which manages the shooting? And the really cool part here about Telescopius is you go here again on this mosaic logo, and here you just click download CSV. And you already see what it says here. You can import mosaic CSVs into Nina, ASIR Pro, and some other stuff nobody uses. But whatever, if you use Nina or ASIR Pro, if you have saved this, you will be able to import it there, and then your software knows exactly the coordinates of these 4 panes, and it will practically automatically shoot them. So very helpful page. You can spend practically as much time as you want on it. So definitely add this link to your favorites. So let's remember the next thing we want to decide is where we want to shoot, right? And that obviously, if we not want to shoot at home, because otherwise it's obvious. So how do we find the perfect place? Also here we have a website, and this is called lightpollutionmap.info. Again, I will put the link in the description below. And so I will show it now according to Europe because I live here, but it covers the whole globe. So the first thing you will see is here overlay, that you can actually choose different overlays. I think by default it's always on World Atlas 2015, but then you see that you have these VIIRs which go up to 2023. So obviously you're not stupid and go with outdated data, but you choose 2023 and you're up to date, right? Not really. VIIRS and the World Atlas map are not the same. What VIIR shows you is where at the ground there's light. So let's zoom in to understand what I mean with that. Switzerland. So we have here, for example, Basel. So Basel obviously has a lot of lights. It gets red. There's villages around it. But let's take, for example, this spot here. There's a hill and it's green. So it must be a perfect place to put your scope in, right? Let's check that now with the World Atlas map. And you see this nice little green spot is completely red. Why is that? Because the World Atlas does show the light in the atmosphere. And that's what we're interested in. Yes, obviously it's great if we're not shooting right under a street light or right in a neighborhood where all the lights are glaring. But what we're mostly interested in is that the atmosphere is dark. So just this little spot here between the villages doesn't really help us. The atmosphere is still as bright as within the villages themselves. So this is really the map we primarily use to find a place. And you can see now that when I click on it, it immediately gives me here the Bortle class 4. So me living right here in the outskirts of Basel, I'm in a Bortle class 5. And as you can see, if I would choose now Basel right in the heart, I'm still only in a Bortle class 6 because in Switzerland we have tiny cities. But let's take now Milan right in the middle. We are already at a Bortle class 8 or 9. The opposite around, if we take our beautiful Alps, we might get into a Bortle class 3. And ladies and gentlemen, when you live in Europe, that's about as good as it gets. Now let's move over to our American friends and we go down to the land of our dreams, New Mexico, or even look at that here, Nevada, Bortle class 1, Bortle class 1. There is almost no light at all. That's the way how we're deciding where to find our dark side. The next I want to show you is my favorite app for astro weather. And that's Clear Outside. It's available for iOS and Android. And what you actually have here is the date and the time. And you see what's red means it's not good for astrophotography. It also tells you when it gets dark. Everything that's black is dark. And then you have again the dawn here. It tells you when the moon is shining and when it's not shining. And then you have the different cloud layers. You have visibility, fog, and the chance of rain and the amount of rain and the wind. And also temperature, the humidity. So a lot of different things to consider. And then obviously your task is to scroll through until you find something like this, where the sky just turns bad at the moment when it gets dark. Great. And that's not unusual. It's what we deal at the moment in Europe for this whole year, that it's just red, 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 red. So thankfully I'm not in the UK, but actually for me it looked almost like that for the last 7 or 8 months. And my rule is, if there's not at least yellow, I don't even consider putting up a rig. Usually I really prefer green. And if it's green with some scattered orange here through the night, then I might consider setting up my rig, but also only if the chance of rain is 0. So again, depends. Sometimes for some testing, also with light scattered clouds, it's possible. It's not so important. If there's a cloud on one side blocking you, you just move it over to train all this stuff. But when you want to continuously shoot one object through the night, it's just heavily annoying if you let it shoot the whole night and in the morning you see that 80% of the shots are not usable because there's cloud on it. So then I rather don't shoot. There's also a second app called Good to Stargaze, which I also like. I will put both of these names in the description below if you ask why 2 apps. It's about the same why 2 weather forecasting apps, because every app, every model shows something different. And with that, we have all we had to do on the computer. Being back here means we are prepared. We are going. And for that, we need to understand how astrophotography shooting works, the theory behind it. How many exposures you need to take, how long they should be, what all the different calibration frames are and how they are produced, and so on and so on. And all of that I will tell you in the next part. See you then, and clear skies.